Good morning guys, I'm Chris and welcome back to this Sunday's episode of Rift Amps. Just to follow up on the J20H then, so just to recap, this one came in flickering dual light and the customer complained that it sounded really muffled and there was a lack of top end. So the dual light issue, I did try and repair the bulb holder, but it did need a replacement. So another one has gone in. Kind of muffled sound. It was actually down on power, down to about 6.5, 7 watts. And so that was down to a blown set of output valves. So I've fitted a nice set of short bottle tabs, which are my absolute favourites. I've also fitted some screen stoppers to the amp, just 470 ohm. It's just to protect those screen grids from over dissipation when the thing is in overdrive, which more often than not these things are these days. So that's brought everything nice and in line. The bias got a nice bias point on it now. So in the last video I said, I wasn't going to comment on this amp because reasons, but I think I can. So the first thing I'm going to say is that these are really, really good sounding Tweed Deluxes. If you're after a really good sounding Tweed Deluxe that's also got its own thing going on, so it's not a vintage replica, it's actually got some nice tonal improvements and its own character as well, you really can't go wrong with one of these from a tonal point of view. The downside of this amp, and it's not just myself that says this, it's other techs around the world who have come across these things, and been in the unfortunate position of having to fix them, is that they're not built very well. They are not engineered very well, and it means that they have reliability issues, which is a shame because it wouldn't take much to make the changes required and build these from scratch, not only to a higher standard, especially for the price point. I think if these were £1,000 or $1,200 cheaper, you might argue for a case that that's where the build quality sits for that price point. But for the price they are, they're not built to the right standard. Now, my main concern is that, as I did say in the previous video, these are not built to respect the legal requirements of the markets in which they are sold. They're not marked as such. They are not built inside as such, especially on the main side of the wiring. And if he's not careful, he's going to get himself in trouble, because they will shut him down, they will fine him, and he will have to go through quite a difficult process to be able to bring his products back on the market if he doesn't bring them up to spec. Now, we don't want that to happen, and I say this about all amp builders. We want to educate people, and we want to say, look, this is where you're falling short. These are the steps you need to make sure your products do comply with even the most basic safety legislation, right? Not even reaching the point of the minimum legal requirements. Just make sure these things aren't going to hurt you if something goes wrong. And so he's, from that point of view, there are things that need to be done inside this amp, and we see it with other amp brands as well. It's not just Lazy J, and Now, the reason I get quite annoyed about this is because I spend a huge amount of time ensuring that my own amplifiers do comply. And I go through the process, and it takes a long time, and there's a lot of paperwork, and there's a lot of things you have to do. But I take a lot of pride in that. I take a lot of pride in knowing that I've ticked every box, crossed every T, dotted every I, to ensure that the product that I'm putting out there on the market is not only meets the most, the minimum safety standards, but is built to a higher standard, a higher international standard. And when other brands don't do that, I get a bit annoyed because, if I have to go through that process, why do other people get away with it? And yeah, it just annoys me. It just annoys me. So I do hope that these things, I'm not saying you shouldn't buy one of these. You absolutely should, but take it to a tech. Make sure it's make sure it's safe to use. Make sure it's, you know, if in the event of a fault, you're not going to get an electric shock and it's not going to catch fire and burn your house down. Which I'm not saying that this one will, but that's kind of the minimum that you should expect as a consumer. So yeah, that's my take on it. I hope that comes across as well-meaning rather than anything other than that, because it's not. You know, I want all amp brands out there to be building great sounding, which this is, safe, reliable, well engineered. You know, we want to raise the game for everyone, don't we? And so, yeah, I think that's enough point on that. But yeah, I mean, the customer's got a great sounding amp here. It really is a nice sounding toneful amp with a lot of character. And when you play it, you get that really nice feedback loop thing going on. I think there are improvements that could and should be made. And in fact, if he's selling them in the UK, which he is, he's got a lot of way to go to meet those minimum safety standards. So, yeah. All right, we'll call it quits. Right, Blues Deluxe. First of all, sorry that this is handheld, but I need to show you something that I can't set up with the tripod. So what have I done? All the cap job is done. Obviously, those resistors were done. New input jacks. We didn't go for the Switchcraft style. I know a lot of people like to mod that, but you know, we are working on a budget here, so we've just gone for the standard Fender style, and they're in there nice and secure. Amps all back in. Fired it up on the bench. No output whatsoever. So just doing some basic checks. Got voltage on all the pins. Got voltages everywhere that I expect to see them. So what's going on? Well, I noticed that V1 wasn't illuminated. The heaters were not on, but there's voltage on the pin. So I was just inspecting the socket, and as you can see, if you look at pin 9, which is that one there, where's it gone? Where's pin 9 gone? Completely missing. Now, I don't understand that, because, get you in even further. I don't understand that, because it was there and it didn't come out when I pulled the tube out originally. So I just don't understand. I do not understand. So I'm going to have to put a new socket in it. So I was hoping to get this one, out the door today, but now I've got to order a PCB mount 9-pin socket. Good news. Just searching through my stash of old weird spares, and I have one Novel PCB mount socket left, ceramic type. Haven't got any Beltons, but God, that's going to save me so much time. So yeah, good news. I'm going to get that swapped in. It means I've got to pull the power board back out again, not the whole board. I can do it inside the thing. So I haven't got to pull the main board out. I can just do the tube board, pull that out, desolder all the pins, and get this one in, and then we can finally get this thing fired up. You know me, can't resist the challenge, right? Thought maybe I could get that socket out without taking the board out of the chassis. Well, yes you can. Here's the broken pin. Pin 9, completely gone. So yeah, the internal part has come off somewhere, I don't know where, but anyway, we'll be able to get the new one in if I can get everything lined up. It's like trying to fish through a post box here, but we'll get there. We'll get there. Come on. Be a winner. Just find the hole. Excuse me. We'll get it. We'll do it. Oh, I hope that one. Go on. Go on, you little winner. Oh, come on. Hold that thought. I am a genius. Look at this. Right, good old slugger solder then. Come on. 1, 2. I'm on count the wrong way out. 9, 8, 7. 6, 5, 4, 3, 2, 1. Well, I've learnt something today. I can replace that socket without having to remove the board, which will save any future repairs and labour costs to my customers quite a bit. Anyway, let's get this thing fired back up and tested. Right, she's on. She's drawing at idle 62 watts out the wall, which seems very healthy to me. Got a loop running into it. Well, that's running and sounding great. That's a really nice sounding amp. I have noticed that this 6L6 is very rattly, so I'm going to talk, well actually both of them are. So I'm going to talk to the customer about maybe fitting a set of 6L6s in it, because they are a bit tired. See what he says. But apart from that, she's all good to go. Rewired for 240 volt, all biased up. All running great and sweet. So all I've got to do now is stick the knob back on, soak test it, fit the valves if he wants it, and then stick the back panel on it. Very, very happy indeed. Update on the Wem Copycat. This is the one that we had in recently, and then it came, customer brought it back because the tape was slipping. Now, I had set the tensioner correctly, and of course I tested it as such. There's even a video on it, so you guys could see that it was all working great. But anyway, he brought it back, and the belt was slipping, and it just required a tiny bit more tension on the arm, that if you pushed with your thumb, it would all start working correctly again. So, we needed to have another look at the tensioner system. Common issue on these is that obviously the tensioner spring, eventually wears out, loses its ability to tension, right? So that's what I assumed it would be. Now, of course, you should never assume, should you? You should never assume. So anyway, I took this thing apart, had a look. Couldn't see any issues, set the tension again, and it was fine. You leave it running, and sure enough, after, it'd take maybe 45 minutes to an hour, the belt would start slipping again. And so now you go, what is going on with this? And you take it back apart, you can't see that anything's changed, you reset the tension, it's all good, put it back together, and it runs fine again. And then slowly over time, it starts to lose its tension again, and therefore not running properly, which is very frustrating because it's quite difficult and complex. Anyway, I took this thing apart, and what I noticed was the spindle shaft on this side, the one that goes through and locks on, was actually rotating in the arm itself, ever so slightly. Now, apparently, it's quite common for the threads in here to fail, and it's a 4BA thread, so 4 British. What does BA stand? Is it British? I should know this, shouldn't I? 4BA, yeah, British Association, yeah. So that's the size. It's similar to I can't remember the size now. Anyway, it's not metric and it's not imperial, it's an old British size. So what was happening was you tension it up. You could even put some thread locker in there just to try and hold it, or whatever. But it was just enough that it just rotated. And then you have to rotate, a smidge a couple of minutes of a degree, and it would lose enough tension where it would start to slip and then, wouldn't work properly, which is very frustrating, right? So it needed a new, this red piece here, which is called, the official name for it is the jockey arm. Okay, there's a lovely chap here in the UK, John Beer, goes by Ampfix, who stocks these bits. Now, I was concerned because the original jockey arm for the unit has this, what we will refer to as a bulge, which on some units holds the erase head, but on this particular model, it doesn't use it, but they did use some leftover erase head holding jockey arms. So obviously this just sat there, but there was nothing in there. It would have been on that side. To erase, well, yeah, so that's what it would be. I've got myself all turned around now. My own head's in erase mode, right? So anyway, he's managed to supply me the slightly later style, Wem branded, of course. And I've put it all back together, and it's now been running for, where are we now? Just coming up on 2 hours, and it's absolutely perfect. Nice and quiet. He provided some shims and bits and pieces to make sure everything runs true. Went through the correct tensioning procedure again. This thing's fine. This thing's great. So it did need a new jockey arm. Customer would, of course, get the original back, but the threads in there are now no longer serviceable. So your options really, if you want to use the original spindle arm, I guess you could drill that out, plug it, re-drill and re-tap if you want to get yourself a 4BA tap and die set, which don't need to because we've got a nice one there. So there you go. So that's the answer on this. I've been waffling on for 5 minutes. I hope I've explained that all right. It wasn't the tensioner spring. The threads in the jockey arm simply couldn't grab the spindle as tightly anymore, and so it was slipping slowly over time. It's all back together now. It's all running nice and quiet, and I think the customer will be very happy. Before we get going, I owe you guys an apology because I didn't take the opportunity to put the Lazy J on the Lazy Susan. So I brought it back for this anyway, because I know some of you will complain. I could actually hear the comment section right now moaning about the Lazy J on the Lazy Susan. Anyway, Selma treble and bass, the old Crocskin beauty. Look at it, wow. Now, I'm actually really excited about this because I've not had a Crocskin treble and bass in before. I've had later versions, but the treble and bass was introduced February 1964. Now, that does not mean that you cannot get a 1963 Crocskin treble and bass, because what the date that they were manufactured does not necessarily line up with the date that they were available in shops. So you can order them and buy them from February 1964, but there are some known very late 63 examples out there. I don't know what this one is. The owner thinks it's a 64, and it probably is a 64. But look at it. I mean, we love Crocskin. Isn't it wonderful? With this two-toner, the black Tolex on the end. Wonderful piece of kit. Quite famous amplifiers. Most of you will know. Some of the North American guys might not, but these are a 50-watt 2EL34 design. Very similar, I believe, to the Bassmaster 50, which was the predecessor, if I remember correctly. Let me just... Oh yeah, the Bassmaster 50 head came first, and then this one came afterwards. Apparently there's not much difference between them, but yeah, anyway. Fun fact, this particular amp, as you can see it's a head, was available with an absolutely massive 1x18 speaker cabinet. unbelievable, right? Absolutely unbelievable. Can you imagine the weight of that thing? But there you go. So what's it in for? I've got a list from the doctor, and it says Selma treble and bass 50 Mark 1, roughly 1964. General service and check over. Well, we can do that. Please test with both a 12A U7 and a 12AX7 in V1. Very noisy with a 12AX7. Please reduce noise if possible. Okay, so we've got some preamp noise going on. Recap if necessary. Make sure old power socket and voltage selector are safe. So it's got what looks like a bulb in here on the back, but obviously someone has hardwired a mains cable in. So we need to check the main side of the wiring inside the amplifier. Got a very old service sticker on the back there. Don't know if that's the last guy who touched this, but we will get into this further. If possible, please fix the upper rear cleat where the wood has split and the section is missing. Okay, so behind this panel there is a cleat that runs along, so we're going to have to do some wood repair, see what we can do with that, and we'll check all that out and make sure it's all good. Okay, here we go. Very occasionally the amp runs away into loud feedback. Then it pops and goes quiet for 1 to 2 seconds. Then it works normally again. Oh, that's odd. Okay, so we'll need to look at that. Turn over. Previously restored by Clive Davis, Barnett Davis amplifiers in East Sussex. Okay. That doesn't appear to be that label. So somebody's been in it before, which, as I always say, is often a good thing. It means that people have, taken the time to look after their pieces of gear. When you see an amplifier that's completely untouched and has not been used, it's been used for a long time but never been touched, you have to ask yourself, well, did the owner actually look after this thing? So very, very cool indeed. So the owner says it works, and he's used it. I think he's recorded with it. He's definitely played it. So I would be quite happy to fire this thing up on the bench and take some measurement, but that's not how we do things around here. Let's remove the back panel. Let's give this thing a visual inspection, both externally and internally. Make sure there's nothing that we spot and find that would give us cause for concern. Then I'll fire it up, because the last thing I'd want is for there to be an issue which would cause further damage that we absolutely do not want to happen. So let's zoom you in. So it's saying we should have a 2 amp mains fuse. So let's check our fuses first. Go on, out you come. And in there we have a... Why can't I read the value? Two amp fuse. Excellent. So it's got a 2 amps main fuse in there. I would probably argue 2 amp is too large for a 50 watt amp. Maybe 1.6 amps is better. But we can measure consumption. Okay, HT fuse should be 500 milliamp. Oh, that's tough. Where's my flathead gone? I was having a bit of a tidy up earlier and I put everything in the wrong place. So 500 milliamp on a 50 watt amp should be a time delay, and it is. It's an RS. God, that's an old fuse. 500 milliamp anti-surge. So it's a time delay fuse. Wonderful. I know it's a bit of a common story, but the amount of times you check a fuse in an amp and it's got some ridiculous value in it. Okay, so rear panel off then. Let's get a cup for our screws. He did say we've got a damaged cleat, didn't he? So we need to be careful. He says, drop in the screw. Most of you know this by now, but whenever I remove panel screws and they've got the cut washers, I always take them off as well. I don't leave them stuck to the panel because do you know how many times I've lost them? They fall off, never to be found again. Okay, so we need to be careful of this cleat. And okay, so we've got some damage this side. And it runs all the way along, but we've got a missing section here. It looks like it's a deliberate cutout though, doesn't it? Why would that be? You see? You can see. Okay, so I can see, what can I see? GZ34 rectifier, 2 EL34s, and 1, 2, 3, 4 preamp valves. Some labelling going on. Output transformer's got the impedance on it, 3.165k. So somebody's been in here and measured this. There's dyno tape everywhere. So four times ECC 83s, but they're saying if you want less drive, you put a 12A U7 in this position. I thought he said V1. I'm sure he said it was V1. Where's the card gone? Please test with both an AU7 and a 12X7 in V1. I'll double check with the customer then which is which. What's in there now? Here's an ECC 82. Well, it's labelled as such. Okay. We've got some can caps in the back there. You see up here? Is that how they were from factory? Right, anyway, let's what am I doing next? Stick it on its nose. 1, 2, 3, 4. So I've got you zoomed in. 1, 2, 3, 4 chassis screws. Now, the way I do this, removing them, is I always have the amp, if possible, on its face, and I do these two first are the ones that are lowest down. So as I undo them, these two are the ones that are going to be holding the chassis in place. Stop, because what I don't want it to do is to flip forward, right? Now, as I start to do these, the transformers are on this side, power transformers here, output transformers in the middle, chokes there as well. So all the weight is on this side. So this is going to be the last one I do. So I'm going to do this one first. It's like paint dry, isn't it? There you go. Now I can already feel the chassis is wanting to pull forward, so I'm going to keep some pressure on the chassis, hold it in place, while I now undo this one. There we go, 1, 2, 3, 4. So now, holding it in place, I can put it back on its bum and gently extract the chassis. Okay, I know there is one viewer who said when I do these top-down views with an amp on a Susan, it does make him feel a bit nauseous. So I do apologise if that's the case, but often it's the best way for me to show you what's going on. I mean, it's probably okay when I'm in this wide-angle view. When I come in close like this, some people really struggle with that. So I will try and minimise that as much as reasonably possible, but again, you know, the Susan is so handy, the Susan, for moving things around that, you know, you'll just have to deal with it. So lay down power transformer, big old choke here, output transformer here, nice beefy one as well. What size is the stack? Roughly, what's that, 1 3/8 or about 35 mil, roughly. Here's your filter cap arrangement. You've got 3 can caps here. I haven't pulled a schematic for this yet, but I would not be surprised if they were multi-section 50-50. So 50-50, 50-50, 50-50. So 6 stages there. Got your interstage droppers. So again, you know, we'll test these, make sure they're all okay. Don't worry, I'm further away from this than it actually looks on camera. So I'm not going to be touching those terminals until I've discharged this properly. Zoom you out. Okay, not really much else to say on here, but I am going to flip it over. So I do need to remove the EL34s. Cool, those sockets are tight, that's good. Electro harmonics. Green print. Okay, just spin this over. Here she is inside. Just check we're not resting on a valve. We are. Pull that GZ34 out, which by the way is an old Edicron. Okay, so power transformer. Voltage selector down here has been disabled. Got a proper DPST main switch, so we are, because we've got hardwire cable, we are switching both the live and the neutral up here. That's a good thing. Screen droppers have been replaced or added in the past. Got some nice bias resistors here with some diodes as well, which are for have we got a bias point on this as well? Oh no, I see. So he's got the HT fuse. Has he? Oh no, he's just using it as a mount. Okay. What else can we see if we zoom you in? Looks like the previous tech has added an internal bias pot. I'll have to check pictures of other ones to check that that's not factory, but it looks like we have an external bias point added. It's had some caps replaced here, so that will be a bias cap there, but the filter cap for the bias supply. Some other bits and pieces done. Oh, it's slipping. Lots of lovely mustards, couple of replaced coupling caps. So you must have had some leakage at some point. Some of the original electrolytics on the board still in place. What a nice amp. What a nice amp. Some shielded cable running through the board. Is that factory or is that aftermarket? I don't know. And yeah, there you go. Okay. So I see nothing inside here that gives me a cause for concern as to why I can't power this thing up and bench test it. We've got an 8 ohm and a 16 ohm socket on the back, so standard impedances. And what a lovely engineered and well-built amplifier. Look at this. Don't get stuff like this anymore. Selma really were doing good quality work, weren't they? I mean, look at it. That's wonderful. Nice quality board, no warping, nice ground points, nice easy to follow wiring. You can see where everything is and where everything goes. It's easy to follow, easy to understand. Let me just go pull a schematic. I want to have a quick look. Okay, the original schematic is available online, but it is quite difficult to read because it's quite a low or poor quality. So this is a redrawn schematic, which is much easier to read and has all the information we could ever need. Look, so we've got all the part values here. So we've got a bomb down here with all the bits and pieces. Got all the values of everything. It's easy to follow, easy to understand. So first thing I want to do is check the value of those electrolytic caps. So we've got C27, 26, 22 and 18. So they are 32 microfarad at 500 volts, so not 50. There you go, I was wrong. There's a choke up here. Interstage droppers are 39, which is a 5K, which is not an E12 value. So the nearest one today will be a 4K7. R32 is a 27K. And that's the dropper down to the first filter stage. Oh no, we've got one here as well, look. That cap isn't labelled. Nothing in here that looks too unusual, to be honest. It's all nice and simple. Nice and simple indeed. So is there anything in here that I need to be concerned about? No, not particularly. The bias supply, I can confirm, has been modified. Which is a good thing. We've now got adjustable bias on it. But yeah, that's the schematic. Nothing really to worry about. So, should we fire it up on the bench and do a basic output check, bits and pieces like that? I think we should. Right, up and running on the bench. It's been running for about half an hour now. So it's nice and cool. Not nice and cool. Nice and warmed up. It's not cool, that's what I'm trying to say. I've got the compi bias plugged in. It's currently pulling 78 watts out of the wall, which is 240 volts exactly today, 350 milliamps. Got the compi bias plugged in, it's all settled down. One valve currently biased to 12.5 watts. And the other one slightly cooler at 10.5. So maximum on an EL 34 is 25 watts. So we are looking at around, or just under 50% of maximum dissipation, which might be right, might be a bit cool. As a rough rule of thumb, as most of you know, as long as that figure ends up somewhere in the 50 to 70% range in a push-pull fixed bias amplifier, then we generally consider that to be a nice operating point. The valves are happy, the amp's happy, nothing's going to get too hot, etc, etc, etc. So yeah, we're on the slightly cool side of things, but we don't know really where it needs to be until we check the output sine wave. So we're driving 8 ohms. I'm injecting a 1 kilohertz 150 millivolt sine wave into the amplifier, and we'll zoom you right in so you can see. Now, just to give you an idea, for 50 watts output into 8 ohms, we are looking for 20 volts RMSing. You're looking down here at this VRMS figure here, the yellow one. So that's what we're looking for, and we should be getting 20 volts at the point of clipping with a nice asymmetrical sine wave. So if I advance the volume control, I'm in the normal channel, input 1. Here comes our sine wave. Oh, and it's already looking a little bit strange. We'll bring it up further. You see we've got a strange notch on this half, on the top half on the slope coming up, and we've got a slightly offset one on the return side. We've definitely got more output on the bottom half of the sine wave than at the top. We'll keep going. I mean, that's not looking like a nice sine wave at all, is it? Point of clipping there. Back it there. So we'll back it down till the peaks are still rounded. 17.6 volts, we'll call that 17.5, which puts us at 38 watts. So we are down on power, but look how asymmetrical that sine wave is, right? The bottom half, kind of where you expect it to look like. Maybe it's a little bit narrow, but this top half, the bandwidth, sorry, the frequency of it a lot wider. But look at those, look at that. Not good. So we've definitely got something going on there, which I'm not happy with. If I just mess around with the tone controls, they seem to be working as expected. Let's bring that back down to 0, and we'll try the bass channel. So we'll go into the bass channel, input 1, advance it up again. Oh dear. That's not happy at all, is it? 2.4 volts into 8 ohms. That's less than 1 watt. Okay, so if I bring the treble control up, so I've now got the volume max, so if I bring the treble control up, I mean, what is going on with this amp? Look at that! Bass control isn't doing anything. Treble control... Yeah, there's something wrong with this amplifier. No wonder he said it's sounding weird. Okay. Back to the guitar channel, the normal channel. Definitely something going on there. The amp smells quite hot, I'll be honest with you, but it's biased quite cold. Can't see any red plating. We've definitely got some investigation to do, haven't we? This is not a typical output sine wave for a EL3450 watter, is it? That's not good at all. Okay. So what do we do next? Where do we go from here? Well, usual things really. Start with the basics. We've confirmed there's an issue with the amplifier, so I need to start taking voltage readings across all of the valves, right? Oh, actually, that's a good point. That's a good point, isn't it? Because this one should be a 12AX7. So if I stick a 12AX7 in there, which is as the amp is designed, then check its output. Maybe that's just causing some issues, right? Maybe that's causing some of our issues. So a brand new 12AX7 can go in. We should also check what's fitted in the rest of them. So that's an AX7, so V3 is an AX7, V2 is a any idea? Looks like an AU7, doesn't it, to me? Is that what's going on with this? V1 is an AX7. Okay. So we've now got an AX7 in V4. Does that change our output? Oh, yes, it does. Okay, interesting. Now we've got a more symmetrical output, but clearly biased quite cold. Okay, I'm going to grab another AX7 and swap that in to this mystery position. Give the amp the correct valve complement. There's no point trying to diagnose something if it's not running as intended, right? So we'll come back. BA, volume down. It was this one, wasn't it? V2. Yep. Okay, so that's 1, 2, 3, 4, 12 AX7s. Right, let's go back and have a look again. Diagnosis live. Let's wait for that to warm up. We're still pulling 78 watts of power out the wall. Okay, so that channel, look at that. Okay, so at the point of clipping, back it down a bit, still biased cold, but we're getting 19.6 volts, which, okay, 19.5 is 47.5 watts. Okay, right, we're getting somewhere now. Our output is back. Let's check the bass channel, shall we? See if we actually get anything on this bass channel. We've got more output, treble all the way up. Yeah, there's still a problem with this bass channel, isn't there? Okay, well, it's doing roughly 50 watts, but this, I need to check how this tone stack is wired. The bass control is doing nothing. The treble control makes it do all sorts of weird things. So, more things to investigate. Right, okay. Are you all following? Come back down here, have a look. The other thing I'll say is these 3 electrolytic cans have been replaced. They appear to be JJ units, so they're not original to the amp. They have been swapped out. So I've got no reason to assume that they are faulty. But we've definitely got something going on in the amp. Now I've got my 12 AX7s all in a row. I'm going to adjust the bias. I'm going to get this now on a chassis stand. Zoom you out. So I'll put this on a chassis stand upside down so I can access the bias point inside, and I'm going to adjust the bias on the scope until we get no crossover distortion, and using the CompuBias we can check exactly the operating point and go from there. Okay, back up and running then. So where was I? EL34, so maximum plate dissipation is 25 watts. So we say our limit is going to be 70%, 25 times 0.7. 17.5 watts is kind of the maximum that we want these to be running at. As in, at the moment, that's the highest I'm going to set it. And go from there. But you could see, I haven't adjusted it yet. Really at the point of clipping now. We're getting, where do you want to put it? We'll call it there 19.2. So we'll call it 19.2 volts or 45 watts. So it's doing 45 watts with some clear crossover distortion. Right. So let's confirm our bias point with no signal going in. Go by the hottest one. Should we call it 13? It's flickering, isn't it? It's flickering. So we can go up to 17, right? So let's go up to 17. 16.5, 17, 18, go back a bit. It's a bit slow to react this. Okay. So we're now at, what's that, 16? Maybe bring it up a tad more. No, the other way. What do we say? 17.5 is the maximum, isn't it? There we go. So we're now up on the hottest one, 17 point. It's flickering between 0.2 and 0.7. Okay, so we'll call that a maximum. Bring up the scope again. Oh, that's looking nicer. Nicer? That's looking much nicer. And so I'm now getting a little bit closer to 50 watts, but there's still quite a bit of crossover distortion then. Still quite a bit. How much do I need to adjust this to dial that out? Okay. I'll just bring the volume down again. It's so slow to adjust this thing. Right. So I think there is just the point. So just as they're rounding off, we've got pretty much straight sides. And as it starts to overdrive, you will get some crossover distortion come in. So we'll call that there. We're getting 19.5, 20 volts, which puts us at around 50 watts. Very good. Right, back to idle. In order to achieve that, I've had to bias them up to 25 watts, right, at 100%. No. Not doing that. Okay. So I'm not happy with this bias supply. I'm not happy with the operating conditions of the valve. It could be the valves themselves. It might be that they are weak valves and we need to stick a new set in, double check the bias point on them and go from there. But this is proof why if I'd set it to just 70%, we'd still have that crossover distortion, so the amp isn't running at its optimum. But to get it to its optimum, I've got to run the valves too hot. So you have to check it both ways. Do you understand what I'm saying? What I want to be able to do is get clean, a clean output sine wave that does 50 watts, and I'd like, we've got screen stoppers in here, haven't we? Yeah, so I would like my plate dissipation to be no more than 80, really. Obviously, ideally less than that, but I wouldn't want to go over that. We normally say 50 to 70% is, you know, is the safe zone, is the sweet spot, but you know, there is a fudge factor in there, depending where the valves want to be. But yeah, I'm not happy with the bias supply, so I need to go through and check that. I'm not happy with the output valves. We've got issues on the bass channel. This amp needs going through with a fine-tooth comb. Just going through a basic process of elimination. So I've swapped out the Electro-Harmonix EL34s that were in the amp. These are the ones that we had to bias extremely hot just to get a clean output sine wave on the scope. I've put in a brand new set of matched JJ EL34s just off the shelf, and I haven't touched the bias yet, so the bias pot is exactly the same position and therefore the same voltage applied to the grids as we have with the Electro-Harmonix, and these ones are running about 5 watts cooler than the Electro-Harmonix ones were. If I advance the volume control, we can see just at the point of clipping we've got a tiny bit of crossover there, but to be honest with you, that's moderately acceptable, and that's doing 20 volts into 8 ohms, which is of course is our 50 watts. So I would be quite confident at this point to say that these electroharmonics valves are reaching the end of their life. It's well known that as valves wear, they do require less bias voltage, so therefore more current run through them to achieve the same output. That's just what happens as valves wear out, and this is a clear example of that. So now we're getting to the point where we're making good progress on the amp. So at 20 watts, so we do 20 divided by 25, which is the maximum. So these are running about 80%, which, as I said, would probably be the absolute top end that I would want to run a set of EL34s. One reason I'm happy doing that is, let me just find the schematic, because I was looking at this, and remember we saw that the screen stoppers had been replaced. Well, on the original schematic you can see there is just a single screen stopper R42, which is shared by both valves, and R42 is a 1K, so that means each side is getting roughly 500 ohms. Now what the previous tech had done, which is a good upgrade, is fitted 1Ks to each valve, so they've now got a higher level of screen stopper there, again helping to reduce that screen current and protect those screens under overdrive conditions and drop that voltage down a little bit more. So I'm quite happy with where this amp currently is. It's not how it's going to finish, but we are making good progress. So I'm still going to go through it and fix all the other issues, give this thing a good service. Customer did say there is some noise in the preamp, which we're going to check out now. Let me get the other microphone, pop it up against the speaker, and then we can have a good listen to what's going on. But you can see just by fitting 2 valves to the amp, sorry, 2 preamp valves and 2 output valves, adjusting the bias, we brought this amplifier back to life. Okay, right, so volume down. What I'm going to do now is signal out. I will boost the audio so you can hear what's coming out of the speaker. So let me just switch to speaker. So this is the guitar channel. We will put the treble and bass at noon, and we'll advance the volume control and have a listen to what's coming out of the speaker. Do you know what? For a 50 watt amp with the volume cranked, that's perfectly acceptable. That's not intrusive or annoying at all. That's great. Right, let's try the bass channel. This is the one where we think the bass control is not working. So bass at noon, treble at noon, advance the volume control. Again, ever so slightly noisy with the volume turned up, but nothing, sorry, with the treble all the way up and the volume up as well. Still can't tell if the bass control is actually doing anything. But again, that's not excessive noise. That's not excessive noise. I mean, there are, you know, hand-wired boutique clones that have a bit more noise than that. So, okay, right. I still want to go through it. Still want to check everything. Take a voltage map, as I always do. Check everything out. There are a couple of components in here that were probably due for replacement just by age alone. We'll check for leakage across any caps. It's already had some done, of course, and we'll take it from there. But this is where I'm going to stop with this for this week's episode. More on next week's videos, but I do need to crack on with some other things. So I hope you enjoyed a bit more of an in-detail look at This Selma treble and bass croc skin version, Mark 1. I don't normally go into this kind of detail on the checkout, but I thought, you know, as you guys are such good viewers, we'll give you a bit more detail there. So yeah, I'm going to go through, do all the basics, tick all the boxes, as I said, cross all the T's, dot all the I's, do all the checks, and then we'll make a decision from there. Well, that's it then, guys. Thank you very much for watching once again. As always, please give this video a thumbs up, or your comments and questions down below. Subscribe if you haven't already. If you're feeling super generous, why not join the channel like these guys have, and I will catch you all at the next one.